I'm joined today by Dave Hillyard from Craig and Dave. Today we're talking about teaching programming in the classroom and sort of more specifically, we're going to focus on a couple teaching pedagogies that Dave has researched and to some extent been a part in creating, and have a couple other exciting things to talk about at the end as well. And we also recently just launched our Teacher Appreciation Week giveaway. So we're giving away, I believe, an iPad and quite a few other things for teachers who register for that. And we have 5 live events happening next week for teachers. That some of them are about coding rooms and some of them are much more general. So Dave, do you mind introducing yourself, your channel, especially for some of our US users? They might not be quite as familiar with your YouTube channel. Mind kicking that off?
Yeah, sure, absolutely. Well, as you said, I'm one half of something that's become known as Craig and Dave. So a little bit of background about me. I've been programming since I was about 10 years old. Creating little games and things like that on an old Amstrad CPC 464. I've got a degree in computer science. I've always been fascinated in computer science and computing more generally, and I've been teaching at an English secondary school since 1997, so I'm about 22, 23 years into the profession now, teaching A-level for all that time, as well as some Key Stage 3 and then more recently GCSE since about 2012. So those are our English qualifications for those aged between 14 to 18 generally. So I've had many roles, some pastoral roles. I've also been head of department, so leading teams of teachers with computer science. I've led teacher training in computer science with the University of Gloucestershire here in England. I've been an assistant head teacher leading the strategy for ICT and computing and other things whole school. I've also been a chair of governors and a vice chair of a multi-academy trust of multiple schools. So quite a varied background, but solidly in computer science and education. So our YouTube channel came about in around 2014. I mean, like all these things, it wasn't an instant hit in 2014. These things take, time to mature, obviously. But what was happening in 2014 was quite special. The national curriculum here in England was changing from ICT to computing. So a shift from digital skills, if you like, to more sort of coding and algorithms, computational thinking, how computers work, that kind of thing. And it was partly because our government had recognised that we weren't really getting enough computer scientists into the industry, and this was costing us, £13 billion or more into our economy, and it was all going overseas. So the government really wanted students to be much more inspired in computer science in secondary school, and to have opportunities in school to learn more coding. That was the idea. The problem was that it's incredibly challenging for teachers because I'm in the minority. Having a computer science degree and background and then going and teaching computer science is relatively unusual actually here in England. Teachers normally come from other disciplines, and that's very, very tricky for a teacher that suddenly went into teaching to teach word processing and spreadsheets and desktop publishing, and all of a sudden they're being expected to teach algorithms. It's quite a challenge. So also in 2014, the exam boards were about to release a new specification for A-level, and every time they do that, there's new content, and all the things that you learnt on your degree come down to A-level, and all the things in A-level go down to GCSE, and it can be quite frightening. And I was also taking an opportunity here to think about how I was teaching and whether there was an opportunity to teach in a different way, because I'd been teaching for 15 years or so at that point, and I felt that my teaching was becoming a bit stale, and so could I actually reinvigorate it and make it more interesting and relevant to my students. And so Craig and Dave as a channel was born. We were looking for a new way to deliver the theoretical content of computer science to students. And YouTube was a way of achieving that. And Craig and I have known each other for quite some time. And we thought, well, instead of us both reinventing the wheel, can we actually plan a new curriculum together? Can we divide and conquer? And then can we share that with the community? Because if we can, all these teachers that are scared about how to deliver computer science theory, particularly at A-level initially and then later GCSE, perhaps wouldn't find it quite so intimidating. So that's the story.
Awesome, awesome. A true grassroots adoption of a free YouTube education.
Absolutely.
Real modern story. So back to our main topic, teaching programming in the classroom. Can you give us a little bit of a rundown about the GCSE and A-level curriculum requirements, and what sorts of pedagogical models you think teachers should be aware of?
Yeah, sure. So there's quite a lot of content in GCSE and A-level, and particularly at A-level, the content has increased quite significantly. And one of the challenges is that teachers don't really have enough time to deliver the content satisfactorily. And that's another reason why we started the YouTube channel, because if students come prepared to the lesson having watched a video in advance, when they get to the lesson, you can save time because you don't have to teach it from the start. So it was about accelerating the learning process and creating more time. But as you might expect with computer science qualifications, there's quite a lot of theory about how computers work, as well as the moral and ethical issues and data structures and many other things. But of course, a core component is computational thinking, algorithm design and programming, which are kind of just lumped together as programming, a bit easier to keep that manageable. And so programming is an absolute feature of GCSE and A-level and is a real core component. Now, the GCSE courses do vary quite a lot in terms of their requirements, but students are expected to know, sequencing instructions, selection statements, iteration statements, arrays and lists, file handling, and those kinds of things. And then at A-level, they're expected to use more advanced data structures, stacks and queues, linked lists, binary trees, graphs, and they're expected to know, lots of the algorithms, the sorting and searching algorithms, the pathfinding optimization algorithms, and all sorts of things like that. They're also expected to undertake a major programming project of their choice where they can choose almost anything they like and create a program from scratch that's really quite sophisticated, and then document their sort of process of developing that piece of software. And that's a massive component of the A-level. So to come back to the second part of your question, which is sort of how to teach programming, if you like. The way I learnt programming was simply to have a user manual and to go through all the commands and the small sample programs in that user manual and type them into the computer, give them a run, see what happened, and tinker, if you like, with a few commands, a few variables. What happens if I add a bit on here? What happens if I change a bit there? And I just learned through a process of trial and error and fascination of the command words. And of course, back in those days, the command words, you probably didn't have more than about 60 or 70 command words in BASIC, and so it was quite manageable. The trouble with today in programming is that there are thousands of commands and thousands of approaches that you can take with those commands. So it really becomes more challenging in that sense. So programming's become easier, but it's also become more challenging all at the same time. But so I think that's how I learned. So in my mind, that's how other students can learn as well, because I don't consider myself special in any sense. But to come back to the second part of your question, I think there are 10 principles, okay? And these are based on research. These are based on Rosenshine's principles, okay? So the first would be sort of a daily review. So you've got to do programming little and often. You've got to do programming as much as you possibly can. And the biggest mistake that teachers make here is to leave it too late and to leave it until you come across that part of the specification. That's not a good idea. Start programming from day one and finish programming on the day they leave, and do as much as you can throughout the entire course. Really, really important. Because what you want, the second principle, is obtaining a high success rate. And William Lau talks about building programming fluency. And that's about repetition, doing things again and again and again, which is why I say you want to do this little and often. And that reduces the cognitive load. Because one of the problems of teaching programming is that students will forget. They're going to forget, how does that iteration work? Why am I using a for loop instead of a while loop? How do arrays work? What's the syntax for this command? So you need to reduce the cognitive load, and you do that by building what William Lau calls programming fluency. So that's number 2. Number 3 is introducing new material in small steps. Now, obviously that's very important, but we ought to be thinking about what is the correct order in what we teach. You know, do you teach inputs and outputs first and then move on to selection statements and iteration statements? Or do you mix that up completely and start with iteration and then selection and then do inputs? And that there isn't necessarily a right way. Everyone's got their own opinions with this. And very recently, I've become interested in the work of Richard Pawson, who says, teach functions first. Now, we consider functions and procedures to be quite a high, difficult, concept for students, so we leave it till later. And it's an interesting thought that when we talk about building competent programmers and getting off to a good start and not getting into bad habits, we talk about sensible variable names, commenting your code, using white space and those kinds of things. Great. But also using functions and procedures, right? Because we want to create modular code. So why is it that we teach that later? We teach comments and sensible variable names first, and then we teach modularity later. That seems weird. And so I think we need to take a step back and think about what is the right order for teaching these things. And teachers will tell you, oh, function and procedures, they're too hard for my students. They're not too hard for your students. It's just you've chosen not to introduce them from day one. That's your issue there. Number 4 is providing models. Okay, so the PRIM model from Sue Sentence is very, very popular. Now, we've taken that because we don't think that acronym makes any sense at all, and we've turned it into TIME, because programming takes time, okay? And TIME is T for try. So here's a program, try it, see what it does. I is investigate. So let's look at the code. What happens if we change this? What happens if we change that? What if we ask these questions of the code? I is investigate. Okay, so looking at the problem a little bit more deeply. M is make. So make your own code. And then E is evaluate your code. So programming takes time. Try, investigate, make, evaluate, and it all makes a lot more sense than PRIM. But in a sense, that's what PRIM is. And it mimics how I learned programming when I was very young. So number 5 is about scaffolding. Okay, scaffolding difficult tasks. So here, what you might do is take a program and split it up into its individual statements or statement blocks and jumble them up and give them to students. That's known as Parsons problems from the university in New Zealand, I believe. Or give students partially complete problems and get them to finish it, because starting from a blank sheet of paper is very, very daunting. Give them code stubs and say, I've done this procedure for you. Now you take that and do the second procedure. So a good example of that is when you're programming a stack, for example. A stack is going to have push method, pop method, peek method, let's say. Give them the code for pushing onto the stack and then get them to code popping from the stack. They've got a scaffold to build on. And then you can from there say, right, now turn that stack into a queue, and it's an easier task than it otherwise would have been. What I like to do in my classroom is give students a ton of challenges and say, here's 100 challenges. I'm not expecting you to do them all, okay? But these challenges are worth 1 point, these challenges are worth 2 points, these challenges are worth 3 points. If you're not very confident, then I want you to have a go at 2 or 3 of the 1 point challenges first. And if you're really confident, I want you to start with 2 or 3 of the 3-point challenges. So every student in my classroom is doing something different at a level that's appropriate for them. And they're doing challenges that they want to do, rather than me saying to them, everyone's now coding this problem. It's not very inspiring for students. So I give them a selection, a basket, if you like, and I say, take your pick. Some are harder than others. And as you get more confident, then take on some more difficult challenges. So I think that's quite important. Number 6 is independent practice. So don't lead programming from the front. Don't say, right, today we're all going to be learning an if statement, and this is what it does, and this is how it works, and you can have a then, and you can have an else, and you can have an else if, and da 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 da. And the reason not to do that is because 1/3 of your class don't get it. It doesn't matter how much you explain it to them, they don't get it because they're not really listening. They're not taking it in. 1/3 of your class are ready to go, and they just need time to practice for themselves. And 1/3 of your class can already do if statements. So why are you teaching them? And so teaching programming from the front is pointless. It just doesn't work in a way that you would like it to work. And the teachers that say, my students are struggling with programming, of course they are. Have you thought about how you're teaching it? So that's interesting. And I believe in agile methods. So I don't get my students to design an algorithm first and then code it. Just get coding, let's just do some agile approaches here. Number 7 is guiding student practice. Okay, so paired programming is a great idea, getting 2 students to sit next to each other, and you can sit 2 strong students next to each other. That's an interesting combination. You can sit a strong student with a weaker student, and all sorts of permutations give you a very different classroom feel. But don't think that students have to all sort of work on their own. They don't. I really like Alan O'Donoghue's stepped challenges. And so this is a principle of where you put the output for a program on the board and you say, this is what it needs to produce as an output. Write the program to do that. And it's completely reversed, because normally we give the problem and we want the students to create the output, but instead give them the output and ask them to create the code for that output. Because what you'll find is that different students will tackle the problem in very different ways. And then coding rooms is amazing for this, because you can say, right, we've all coded this, we've done it in slightly different ways. Let's have a look at student A. What have you done? Why have you done it that way? Let's compare that to student B. What's the advantage of this approach over the previous approach? And you get some real rich conversations by doing that. And it's only with tools like coding rooms that you can really do that successfully, I would argue. Number 8, we're nearly there, but it's all important. Number 8, ask questions, okay? So spend more time with individual students and less time from the front of the classroom, okay? And when you ask questions, I use Carsten Schultz's block model method of this, okay? So ask questions about the keywords they're using. What does that keyword do? Why have you used it? Why does that need a parameter? Those kinds of things. Ask them questions about the structure of their code. So why have you chosen to create a procedure called this? What does this loop achieve? What would happen if I change that for loop for a while loop? Those kinds of things. Ask them questions about the purpose of their code. So what does it, why does it work in essence? And then ask them questions about the reason why it works. Why have we chosen to do this instead of that? And talk about the approach that they've taken. Okay, so ask lots of questions, but not from the front of the classroom, because it's not very effective. Ask individuals. Number 9 is checking understanding. Circulate in the room, as I've said. Lots of oral feedback. There's no point getting students to print out their code and then mark it. No point marking their programming. Waste of time, if you ask me. What's much, much more effective is oral feedback, okay? Talk to students about the programs that they're writing. Now, I've got a whole oral feedback framework where we ask questions about comprehension, maintainability, scalability, robustness, and approach, and I could break that down further for you, but in the interest of time, I won't. But I've got a framework for these oral conversations. And then finally is a weekly and monthly review. So track progress, all teachers do that, and have milestones. And so what I tell my students is, I expect you to have done X number of challenges by this point and Y number of challenges by that point, and I allow them the freedom and flexibility to work within that framework at their own pace. Those learners that are falling behind are clearly struggling. You can spend more time with them. Those that aren't struggling are flying, and they're doing far more challenges, and they're going at their own pace, and that's great. So in a nutshell, although I'm not sure it's a nutshell, but that's how to teach programming. 10 key concepts based on Rosenshine's principles.
Awesome. Where can people find a good reference guide? Is that available on your website? I think I found the presentation.
That is a great question. We do have a guide on our website. I'll tell you what I'll do. I'll create a new tile on the homepage of our website, How to Teach Programming, and I'll link off something to there, and you can grab all this good stuff. Okay. It'll take me. I'm at school tomorrow, but it'll take me a little while just to get that up and running. But I'll do that, and I'll put it on the homepage for you.
Mm-hmm. Yeah, that's awesome. It's definitely something that I think we're keen to share with our community as well. So if anyone who's listening, you can post your comments to any of the places where this is posted, comments or questions. But I have a few. Right off the top of my head. The first one is, so teachers who and I think you'll agree with me that this is the case quite often. Teachers who themselves are maybe picking up programming for the first time. It's their first year teaching. How do you think they can apply these principles? Have you worked with teachers who maybe are just picking up maybe Python, their first year teaching Python, and they're kind of learning with their students? Mm-hmm. How do you find, how do you think they should prepare for doing things like having these oral check-ins with students? I mean, it can be incredibly challenging to have one of those if you're not kind of, if you can't look at 20 lines of Python and kind of know exactly what it's doing like immediately, which is something that you get after maybe 2-3 years of teaching it, at least.
I want to challenge you a bit on that, actually. So I think in many ways, if you're not a confident programmer, maybe you're in a stronger position. Let me explain, because when I look at a program from an experienced teacher's point of view, and I've been programming, for 30 years, more than that actually, I look at a program and I'm instantly looking for it to be better. I'm instantly looking for, well, that's not very robust in that validation, or I'm not sure I'd have used it, or you should be using a function for that, or all of these high level things that you'd expect a very experienced programmer to be bringing to the table. And that doesn't always do my students favors. If you're inexperienced, then you genuinely don't know why a student's done it in a particular way. You don't know why it works the way it does. Well, doesn't that give you a rich question set to look at the program with the student and say, tell me why, tell me how? And I don't think it matters whether you're experienced or not. If a student's written a little bit of code, then they should be able to explain sort of what it does, even if they can't use the right terminology to explain it. I think they can certainly still explain their method. They can explain the problems that they're getting, and they can explain why the solution does what it does. It isn't necessarily the most elegant solution. It isn't necessarily a solution that I would look at and say, oh, I'm not sure I would take that approach. I think you should think about this. Okay, and an inexperienced teacher won't do that. But that's not a problem, and learning with the students isn't a problem either. I said to my students a little while ago now, because I was interested in doing some games development, and I've got no background in games development at all. And I said to my students, look, I found this IDE called Default. It's really good, but the code base is Lua, and I don't know anything about Lua, but it looks cool. Are you interested in giving it a go? And bear in mind, I've never programmed in Lua, so don't ask me for help, but shall we give it a go together? And it was an amazing experience because they got ahead of me and they created these little things. And I was like, wow, what's this? And there are all sorts of new data structures that I'd not used before, things like vectors and those sorts of things. And they were able to teach me, and they felt really good about that, and I felt really good about that, and we kind of learned Lua together. So don't be intimidated by the fact that you don't think you know as much as the students. You will never know as much as some of those students, and I've got students today that create things in Java. I've never written a line of Java code in my life, but they can do it, and that's all I'm doing. I'm giving them a framework for them to be successful. I don't have to be successful in the same framework.
Mm-hmm. I see. I'm not sure, Dave, are you able to see some of the comments on the...
I can't see any comments. It says comments are not available for me.
Okay, I'll feed a few of them to you. The first one about flipped learning is something that we have on the docket for today that we'll come to in a bit. I know, Dave, you have a lot of thoughts on that, or the flipped classroom model. And a question about the Java, was it with Roblox? I think that's a game.
Yeah, I know what Roblox is.
Yeah.
Yeah. What was the question?
The Java programs that your students are writing, were they with Roblox?
Oh no! Sorry, no, they weren't. They were just programming some games, just you know, from scratch, just little shoot 'em ups, you know, that kind of thing. And this happens in my classroom. So I'm like, oh, let's learn Lua. This will be really good. And then there's a student that's like, well, I've been making a few games in Java, and I'm like, oh, have you? Oh, great. Well, crack on, you know, show me. So. No, it wasn't Roblox and that kind of thing. I did have somebody make a Skyrim mod once, I think. I think that was in Lua. I'm not really sure, but yeah, I tend to let my students sort of as much as I can. I've got to obviously get through the content of the course, but I try and let them get inspired in computer science. And I think sometimes if you put too much of a framework around learning, which is essential to a certain extent, but if you put too much of a framework around learning, then you're not allowing the students to get inspired in the subject, and you're clipping their wings. You see, the thing that I really loved when I was young is that nobody was telling me, write this program, write that program, learn this, learn that. I was finding out for myself, and I was following my own journey and my own pathway into things that I was interested in. And so I just try and give my students that same sort of freedom, if you like. You know?
Yeah, I know this isn't directly part of your, although sort of indirectly, I guess this is all sort of related. But I'm really curious about that specifically, because I picked up programming, you know, outside of the classroom. Kind of much in the same way that you did, although not with games, but with hardware. And I worry, you know, especially sometimes, you know, we talk about all these in the US. It's really common, the sort of CS for all mentality, that every student has to learn CS, and so inevitably every student gets put into a pretty square box of what computer science is, what they need to learn. And I feel like for me that wouldn't have been a problem after I already got excited about programming. But if that were my first encounter with it, I think I'm not sure what that would, like how that would change my trajectory if I, you know, just said, this is really boring. I'm kind of, clearly this is definitely not what I want to do. And so, especially when we talk about like Scratch intros and stuff. I know for a fact if someone told me about Scratch when I was in middle school or something, I would have never taken a programming class. And that's not a knock on Scratch or block programming or anything like that. But I feel like there was some element to hacking something that got me excited. Hacking something, building something, just like taking things apart and maybe putting them back together. Like that was the real magic for me. And I still feel like to this day, just today I was learning Elixir after I did some of my main job stuff on coding rooms. And it's just because it's kind of thrilling for me to pick up something new or to feel like I'm just working on something that for me is just intellectually pleasurable, right? And I'm sure you know more specifics about what teachers can do to make sure that they cover all their bases, but also that they don't prevent students from being excited about comp sci, as sort of counterintuitive as that might sound. What are your thoughts on that?
Yeah, well, it's interesting. You used the word that was in my head as you were speaking, and that was magic. And computer science for me, as I was growing up, was magical. It was the thing that most other people weren't doing. And one of the problems today, of course, is there's not so much that's magical about computer science because students were born into computer science. It's not a novelty. And they use computer science for completely different things, entertainment and keeping in touch with friends and all these kinds of things. And so they have different expectations of computers and what they're for. And that's a challenge in secondary school. And I don't know that I've got the complete answer to that, but I think what you have to do in many ways is try and give students as many hooks as you can and just see which ones they actually latch onto, A bit of an analogy, I suppose. You could put your fishing rod in the water. It doesn't mean that every fish is going to catch that bait, and so put different bait in the water and those kinds of things and, see what bites. And I think one way that I do that, for example, is that I'll give students little programs and then some of them they'll enjoy and some of them they won't. And the ones that they don't, move on from. The ones that they do, it's like, well, how could we expand that further? How could we increase the functionality? One of the ways I like to do that is with simple text-based adventure games, which look quite boring on the surface of it. But they're so open-ended, and you can say, okay, so the character can go here, they can go there, they've got this inventory, this item does this item does that. And you can make text adventure games very simple, you can make them very, very complicated, but they're easily expandable. And so you can say and then the students get excited because they're like, well, could I create a shield object so that my player takes less damage if they're in a fight? Yeah, go for it. How are you going to do it? And I can have conversations to them about the appropriate ways of maybe approaching that problem. And so trying to find things that interest them and let them kind of go in those directions. And that's an interesting thing to do. But I think what you also have to do is look at learning holistically. So we're talking about programming specifically, but if you take that mindset into all your learning, not just programming, then it becomes more natural for students to look for those opportunities. So for example, when I teach a theoretical concept, I get them to demonstrate their learning of that concept, and it's up to them how they do it. Now, what does that mean? It means that for some students, they might choose to make me a little presentation. For other students, they might choose to just write me a paragraph or two of text. Other students might choose to make me an animation. Some students might want to record a little video clip. Some students might want to write a little program that illustrates whatever it is, Are any of those outputs unacceptable? Why should they be? If a student says, oh, I can explain the von Neumann architecture by making a little animation, well, why would you stop them? Now, if they take that mindset beyond learning theory and into programming, it becomes more natural because they're like, oh, I could do this, I could do that, I could write this program, I could expand that program. So it's as much about a learning mindset as it is about the programming itself.
I see. Why don't we move on to the flipped classroom piece, since you had a comment about that and it's on the agenda. Flipped classroom, I wouldn't say it's a particularly new model. I'm sure a lot of people are, at least on the surface level, sort of familiar with it. Can you explain your definition of a flipped classroom and why you think it's useful in CS?
Yeah, absolutely. So in essence, I want my students to come to the lesson prepared with the knowledge that I would have taught them from the front of the classroom if I was going to do that. So for me, they watch a video on a core concept and they write notes in a notebook, and we structure that using the Cornell method. And then they come to the class with those notes and they have a baseline of knowledge. So I'm not going to then stand at the front and teach them that, because that was the purpose of the video. Now, for people that don't like videos, that can be a page in a textbook. It can be anything. The point is that they're learning the core theory outside of the lesson. They come to the lesson and then you can start with what did you learn in that video? What was the most important part in that video? What did you learn about this concept? Why was that important? And you're not spending 20 minutes trying to get to that question set. You start the lesson with that question set. Then you just give the students little mini activities to do. So here we go. I've got 5 activities. Doesn't matter what order you do them in. You don't have to do them all. Have a look at them. Go. And they'll do that, and I'm circulating in the lesson while they're doing that, and I'm spending a lot more time with individuals. That's the critical thing. So students are choosing what they're working on, and then I try and split the lesson in half. So half of the lesson is theory and half of the lesson is programming, as much as I can, and that's how that works. So in essence, in summary, the activities you wanted them to do at home, do those in the classroom. The activities that you would normally do in the classroom, like teaching, get them to do that at home. That's what it is for me.
And do you teach everything like this, or is this only a model that they use for certain types of content?
I don't teach programming like that, in the sense that I don't get them to watch a video and then, bring that knowledge in and then start writing programs. I get them to, because I don't need to, I get them to write the programs, in class, type this up in class, give it a go, whatever. I could teach that flipped. I just choose not to. But the theoretical content of the course, absolutely, everything is flipped learning. Now, one of the criticisms sometimes you get from that is, oh, your lessons have become formulaic. So they always watch a video for homework. They always come into the lesson. They always do activities. You always do the Q&A. Every lesson's the same. Well, if that's what you're doing, then you're abusing the flipped classroom pedagogy. That's not what it says. It doesn't say every lesson should be the same. It says, get the students to do the learning outside of the lesson, and then you can accelerate the learning in the classroom and have deeper conversations. That's effectively what it's saying. So do I still do class, whole class activities? Do we still have fun? Do we still mix it up? Of course we do. And if the class come in and they say, we really don't understand this part of the video, and I'm getting the vibe in the class that's a lot of people are in that situation, then I'll stop the whole class and I'll say, right, a lot of you are struggling with this. Sarah, you're not struggling with this. Perhaps you can explain to the rest of the class what this means, because you can probably do a better job than me. Come up to the front, tell everyone else what you know about this. And so, we do that as well. So I don't want people to think that flipped classroom is the kids do all the learning outside of the lesson. No, of course they don't. They do some of it outside of the lesson.
And I guess the couple obvious follow-ups. So I don't know what % of kids do homework, I guess. In CS, I assume it's probably higher just because it's more of a, you kind of have that, volunteer bias, right, for CS. But yeah.
I think that's a dangerous assumption. I think kids are kids, okay? And just because they're doing computer science doesn't make them any different to those students that aren't. I mean, okay. they're just more interested in that subject than they might be in other subjects. In the same way students that maybe have chosen geography instead of computer science, are they more likely to do their geography homework? Well, perhaps, but does it mean that everybody does geography homework because they've chosen geography as one of their subjects? No. And the same is true in computer science. So it's a bit of a myth that the flipped classroom solves all your problems. All of a sudden every problem you ever had in teaching is solved because of this thing called the flipped classroom. No, that's rubbish. Do you get students that don't do their homework? Yes, of course you do. The question is, what do you do about it? And this is the thing that I find really intriguing, because I do get asked sometimes, oh, my students won't watch the videos. Right, okay. Did they used to do their homework? No. Right, okay. What did you do about it? I put them in detention. I did this, I did that. I said, well, why have you stopped doing that? They're still not meeting your expectation. Don't expect the pedagogy to fix the problem here. This is down to what you're doing as a teacher and what your expectations are. But I'll give you a few tips, okay? So the first is, the students that are probably less likely to have done their work, right? Now you've got a choice as a teacher here. You can either do that quietly and not draw attention to it. So when you do your Q&A thing at the beginning of the lesson, don't choose them because they haven't done it. Then when you're circulating around the students because you've got more time, ask them to have their notebooks out on the desk with their notes in front of them, which they need to help them with the activities anyway. And then you can go around and you can say, well, your page is blank, or you're on the wrong page, or where's your book today? You haven't got it. You've put yourself at a disadvantage. How are you going to do the work? It's going to be very hard for you, isn't it? You're going to have to pair up with someone else in the classroom and hope they're going to be kind enough to support you. It's not ideal, is it? So that's a softly approach. The harder approach is to choose something that is a very easy question to answer from the video and ask the whole class, okay, put your hand up if you know, blah, blah, and everyone is going to know this because it was simple. And most of the hands will go up. And then you pick the one that didn't have the hand up because they're trying to kind of, disappear into the back of the classroom. Right, what do you think's the answer? And they're clueless. They don't know because they haven't watched the video, see? And they're desperately trying to look over their friend's notebook, see if they can see the answer. And then you just push them a bit. So, what do you understand by it? Meanwhile, the rest of the class go, sir, and they start to feel a bit silly. And over time, if you've got high expectations, and it's not unreasonable, they will meet your expectations. The problem that you've got in teaching is thinking they're not going to meet your expectations. The moment you think that, they won't. So you have to have the high expectations. It's the most critical thing that I teach on teacher training, is teenagers will sniff out your body language quicker than anybody else in the world. If you give them the impression that you're not serious, if you give them the impression that you don't really know what you're doing, if you give them the impression that it's okay for them not to do their work, then they won't do their work. So you have to turn that on its head, right? So it's a myth. I can't do flipped classroom because my students don't watch the videos. Well, you're not making them. That's the problem there.
Yeah. I guess it's a very logical solution, right? But sort of non-obvious, I guess, at least for people who aren't as familiar with this methodology.
I say to my students, look, out of all the subjects that you've got, I am going to give you the easiest homework, okay? And this is the deal. This is my homework. You watch the video. The video is no more than maximum 10 minutes long. Most of them are shorter than that. You watch that video and you make some notes. Now, if you're at GCSE, which is 15, 16 years old, for those that aren't in the UK, then I give you a short slide of notes at the end of every video. You pause the video. I even give you a little icon in the corner to tell you this is what you should write down. You pause the video and you write that in your book. So all I'm asking you to do is to watch the video, pause it at the end, write the notes, bring those to class. I guarantee you there's no other teacher in the school that is going to give you as easy homework as that. So if I'm going to make your life that easy, surely you can do the work, right? And they start to realize, actually, this is pretty straightforward. Now, I could do you a whole podcast just on homework and what good homework should be and why it should be like that and all the rest of it. But I'll give you just one little part of that, which is don't expect the parents to help the students with their homework. If you're setting homework that the student can't do, either because they didn't learn it sufficiently in the class, or they're going to need, some of them are going to need parental help, you're setting them the wrong homework. Set them homework they can achieve, and then they'll do it. If you set them homework they don't think they can achieve, don't be surprised if they don't do it.
I see. Yeah, that's interesting. I'm also curious. So does homework, do you think homework should factor into a grade?
I don't let it, okay? Because the purpose of the homework is to prepare them for the classwork. And so I'm not really interested in marking their homework and putting that towards a grade. I'm interested in, as a result of having done that homework, how well can you do the classwork? And then I will mark the outcomes of their classwork. So as I was saying earlier, a student may choose to make an animation, they may choose to write a Word document, they may choose to, create a little video clip or whatever. All those are perfectly valid outcomes. And I will mark that outcome, and I won't mark the homework because I don't need to. I might acknowledge it because my school says, you have to mark homework. So I might acknowledge it in some way. But I'm more interested in, okay, we're using the Cornell method of note-taking here. So having watched that video, what questions have you got? That's more important to me. What questions are you asking me in class? And if you're not asking me any, then you are either a genius or you haven't done it.
I see. Yeah, I asked that question because at my high school, there was one year that they just gave up on grading homework across the entire school.
Yeah.
And my GPA fell by like an entire point because I just didn't do anything. And so I'm interested on that. I guess I'm not like a sort of 50th percentile student, right? Like you shouldn't model anything after me, but I'm kind of interested in what happens at the extremes, like how different students will react to things.
If I wasn't teaching flipped classroom, right? If I was teaching traditionally, let's put it that way, I think I could probably teach an entire course having set no homework and still get the same outcomes. I don't think homework in that sense is worthwhile. So that's why I give homework a real purpose. It's an interesting debate, and I think we could have a whole conversation on homework, because there are students that do a lot of homework. And as long as it's not too much and it's creating other sort of mental health issues, if it's an appropriate amount of homework, are they getting benefit from that? And there's no doubt that some students will be. That, I'm not saying that homework is a bad thing, but homework must have a purpose, a clear purpose. And if all you're doing is setting homework because you've got to give them something to do outside of the lesson, that's poor teaching. Everything you do should be done for a reason. So if you're setting that piece of homework, why are you setting it? How are you setting it? What are you expecting as an outcome? What's the learning advantage of it? And if you can't articulate the learning advantage, then there's no point setting it, because it's not going to have any effect.
Mhm. Yeah, there's a comment on the video. There's a big push in the U.S. for having no homework. It's not good. They all act like Sasha. Yeah, I can say that.
You know what, I'm up for that. But if we do, then I need to rethink the flipped classroom, because the flipped classroom relies on them watching this video outside of the lesson. If they can't do that, if I strip that out, then I've completely broken the flipped classroom. So I have to look for a new pedagogy. Now, I'm pretty confident I could find a new pedagogy, because there isn't one holy grail of pedagogy, because if there were, everyone would be doing it and everyone would be directed to do it by the government. But there is no magical way to teach. So if you take homework off me completely and I can't have any homework, I'm up for that. I think there's a lot of educational advantage in not having any homework, but I have to now find a completely different way of teaching, which I would do, and I'd be fine with it. But whilst I have got homework, I'm going to take advantage of flipped classroom.
Yeah. I mean, it's completely different if you build an entire model around not having homework. I think like the more challenging case is you build an entire model around not having homework, and you make homework an optional part of that model, and then everything just explodes.
I think you're on something. Students have to know why they're doing something, you know. Students don't really like, well, no, let me backtrack. I was about to say students don't like being told what to do. Actually, they do. You know, teenagers like structure. They like to know where they stand. They like to know where the boundaries are. And if they don't, that's when they start flexing them a bit. All right. So it's not true that students don't want to be told what to do. However, they are also growing up, and they're also finding themselves, finding out who they are, what they're going to be. And they can resent sometimes being told certain things. And so, yeah, I think, that can play its part.
Mm-hmm. That sounds like its own podcast, maybe. we should tackle. Get some students in and some teachers. See what everyone thinks. But I definitely remember being told what to do was like a very important part of any successful class that I took, or any class that I took successfully, I guess.
The role of your teacher is to set you on the right direction. Okay. But within that, you have to have the opportunity to flourish. And the way that you learn is with failure. And, this is another mistake I think that teachers make. You have to allow students to fail. I mean, coming back to how do we teach programming? How many times have you written a program that runs and executes perfectly first time? Now, I've been teaching and learning programming for over 30 years, and even now, that doesn't happen to me. Of course it doesn't. You run the program and you get a little bit of feedback. If you've got a good compiler, then you get some feedback, right? And chances are that error that the lexical or syntax analyzer has tried to give you is a bit cryptic. It points you roughly in the right direction, and then you have to try and work it out from there, right? And you work it out, and sometimes the problem isn't in the line that it's highlighted, it's elsewhere. And if you get a logic error, so the program runs no problem at all, it just doesn't give you the output that you expect, then you have to go back through that methodically and look for, well, what's the error that I've made here? We learn by failing. And so if you're always being told, do this, do this, do this, you can't fail, these are the boundaries, I'm not going to let you fail. That's not how we learn. That's not how we learn as human beings, is it?
Yeah.
So
that part really, I almost take issue with the categorization of like an error in a program as failure, I guess. It wasn't until recently that I started speaking with a lot more teachers that I realized that like running a program is something that students they feel like there's kind of, I don't know, maybe that they're submitting it or something. Because for me, running a program is like, let's try it out. You know, that's just,
Exactly.
that's not even, that's not a, that's a totally, like a step in the process of writing a program. It's not the end game.
I agree. I mean, my point is, did the program fail or did it succeed? Well, if it crashed or it gave you the incorrect output, then it failed in its task. But the process of writing the program wasn't a failure. And I'm completely with you that we have to take these incremental steps in order to get to the solution, to get to the learning. That's right. Yeah.
But, and I think now that I think about that, that is very different to math, for example. Like, I don't take incremental steps to math problem. I solve it, and the steps build on each other. Like if you're building a proof or something. So if you make one step wrong, then you kind of just snoop the whole problem, and that's it, and then you failed the homework, whatever. But programming is fundamentally different. Maybe that's something that ought to be. Maybe that's something that has to be explained to students. So, like, it's an iterative process.
Maybe, I don't know. I mean, if you think about solving an equation, it's a little bit like writing a program, I would argue, because there's a logical sequence of steps, of instructions, and you follow them in a particular sequence, and you do this and you do that, and that gives you an output, which is right or wrong, okay? But the method was similar. The difference is that a computer gives you instant feedback. So you can make the incremental step, you can give it a run, and you can see what happens. And it's like, oh, yeah, it's good so far, let's do the next step. Or, oh, no, it crashed, right, let's fix that, now let's do the next step. The problem when you're solving an equation on a piece of paper is you've got no feedback. So you don't know whether you're on the right track or you're not on the right track. And that's the beauty of programming.
Mm-hmm. Yeah, I always hated. I always wish there were like a ID in math class. Give me autocomplete and everything for proofs and stuff like that. I think that's missing. I'm sure that exists in more professional settings, but I'm sure I would have loved to have had that. And for me, an IDE was part of the learning process too. Like, looking through autocomplete or reading through the red squiggly lines was always kind of part of, kind of like a secondary teacher for me almost. Kind of like Clippy. Do you remember Clippy?
Yeah, of course I do, yeah.
Yeah, kind of like that.
Yeah.
So one of our last points here, because we're coming up on time, you talk and through your work, you talk a lot about more recently the remote learning trend and how a lot of the pedagogies that you created earlier fit really well into the remote teaching model. I'd love to hear more about that.
Yeah, so it's interesting that being hit by a global pandemic has in many ways turned teaching and learning upside down, and teachers have had to become very familiar with technology overnight, and they've had to learn to deliver lessons in a completely different way. And that hasn't happened to me. And, it's been easy for me to teach during the pandemic, not because I'm a computer scientist and I can use the technology, because other teachers have successfully done that as well. The difference is I haven't had to change the way I teach. That's the significant change here. My students are used to being prepared for the lesson, for watching videos in advance, making notes, coming to the lesson with questions, getting ready to undertake activities independently, choosing from a little batch of activities they could do, which ones that they want to do and how they want to approach it. So for me, the pandemic hasn't changed teaching for me at all. It really hasn't made any difference. I haven't had to do any additional planning because all my activities were already prepared. They're already based on an independent learning approach. I've already got all the videos on YouTube that the students can watch. and there's no change. And coming back to videos a moment, it's worth knowing or noticing what's the advantage of doing videos. Okay, and what I would say is that not only have you created more time because they're prepared outside of the lesson and you've got that baseline knowledge, which we've already talked about, but it's encouraging that independence, putting the students in control, so that when they are in a situation where they're not in a classroom, they're used to being independent and they're used to being in control. Students can pause a video, they can rewind it, they can rewatch it if they don't understand. It's very difficult to do that in a classroom context where you're at the front and you're explaining something to students and they're sat there and they don't really understand it. Well, with video, pause, rewind, watch again. Absent students are never left behind, and that's amazing because they've all got those videos. If you miss one of my lessons, you don't actually miss anything because you've got the video, and I've already given you I've already made available to you online the activities that we could be doing. So no absent student is ever left behind. And because every video is no more than about 10 minutes long, there's no irrelevant waffle. I mean, I've spent an hour talking to you, and I bet probably 70% of what I've been talking about is just waffle, because the important bits are probably down to about 30%. And so when you challenge yourself to make a video on something that's only going to be 10 minutes long, you can't afford to waffle. You have to kind of keep it sharp. And so the pandemic has not had any impact because I've got all those advantages of video that I had before, and nothing's really changed, if I'm honest.
And has that been contrary to some of your other colleagues who weren't teaching this way?
Yeah, because those teachers have found themselves having to do an awful lot of planning. They were anticipating being in front of the class and being able to talk from the front, ask questions, use the resources that are in the classroom, and do activities in those ways. And because I've planned my activities to be taught differently right from the outset, it means that it just hasn't been a problem in that sense. So yeah, my other colleagues have had a hard time. It's been very, very stressful, and it's been very all-consuming, and they're absolutely exhausted, and they're being expected to teach in a way that they're not familiar. And for me, I'm just really blessed because I didn't see this coming, of course, but I was in the perfect position when it did come. So whoever invented the flipped classroom, and I know it started out in America, so I think it did anyway. So I want to give my thanks to all those American teachers that might be out there and might end up listening to this. So thank you. You saved my life this year.
Yeah, I mean, it sounds a lot easier than what I've heard a lot of folks going through. So that's awesome. And lastly, what are your predictions for the future of teaching computer science, and specifically at the high school level? I think is interesting, more applicable to our audience.
Yeah. Well, it won't surprise you that I've probably got quite a lot to say about this as well. I'll try and keep it as brief as I can. I think, firstly, we've been accelerated in education at least 5 years. Everything in education normally happens really, really slowly. Things that are happening in businesses, eventually sort of trickle down to education, and then we play catch up. I think what this has shown is that you can teach in different ways. It's not always successful. Nothing is always successful, but it's shown us you can teach in different ways. So I think that in the future, we can anticipate a much more hybrid approach to teaching. So it isn't always the expectation that you'll be in front of your teacher in your classroom. You don't always necessarily have to have that teacher. And I'm quite interested in the sort of international angle here, that if I've got a class and they're learning anything actually, but let's say learning Spanish, why can't my Spanish teacher be in Spain? Do they have to be in my classroom at the front of my class? Do they? And I think, that could be true of all subjects. And so I think a more hybrid, a more fluid learning experience is something that we can anticipate moving forward. I think there will be, this is a catalyst for it, and I think there'll be a greater infusion of technology in the classrooms. It was beginning to happen anyway, just very slowly. So more one-to-one devices, more students, you know, having tablet technology and bringing a digital device into the classroom. Virtual reality, augmented reality, I think is a very interesting concept, where they might have their device and they might, you know, shine the camera at what would have been a textbook, and all of a sudden you get animations and things coming out of this textbook, those kinds of things. And a whole, you know, wealth of learning apps, which we're involved in here at Craig and Dave as well. I think you should anticipate a greater focus on the skills that are needed for business. And I think education has become too sort of narrow-minded in what it's doing. And I think that it's probably about time that we created students that are fit for the future. And some of the things I've been talking about the way I teach, I think those are the ways forward. So developing students' emotional intelligence, developing their collaboration skills, developing their decision making, developing their adaptability, their creativity, their resilience, their time management, and just having this open mind to a continuous learning journey, you know. That the teacher isn't always going to tell me, do those questions on page 6. How am I going to demonstrate my learning? I'm going to choose to answer the questions on page 6, or I'm going to choose to create you a little podcast. Why not? I think this is probably the last thing I'll say on this. I think there's a disconnect. Particularly in England, I can't speak for the rest of the world, but I think there's a disconnect between head teachers and our economy. I mean, some teachers have become skilled in computer science, but we're still struggling to recruit graduates of computer science into education. And, you know, why is that? We need to sort of address this. And I know that our government have been pouring a lot of money in recent years into computer science education, and it's having some impact, but it's not having the impact that I would like to see. You've still got schools that are dropping the subject because head teachers don't value computer science. There's low take up in the school, and they don't try and do things to increase the take up. They just say, oh, students don't want to pick computer science, we'll drop it from the curriculum. So it's this problem of, I can't recruit the good teachers. I've got no incentive from the government or from Ofsted or, you know, whatever regulatory body you've got to put pressure on the schools to make sure they deliver this in a very, you know, strong way. You're overburdening the teachers and not giving them the freedom to teach in a way that's going to make some sense. Too much bureaucracy in schools, and you're just not putting the head teachers in a place where they are thinking about why the students are learning, and they're not learning just so that you can get good school results, you know. And that's a misconception. And oh dear, I don't know, I could talk for hours about all this, but there you go. That's the future of computer science. I don't know whether it's promising or whether it's bleak, but I'll try and do my best to make it promising.
I see. Yeah, that's yeah. I was about to say there just sort of two positive, or at least one positive, one neutral, and one overwhelmingly negative. But I definitely hear a lot of your points on that. One thing that came to mind immediately when you said fit for the future, I thought, oh, okay, so, you know, you want people to learn JavaScript or whatever. But I'm actually really pleased to hear that they were more the high-level skills and not this sort of like vocational stuff. When
I started learning computer science, JavaScript didn't even exist. What I learned.
I wish it still didn't exist.
Yeah, I'm with you with that. But Yeah, I mean, in many ways, computer science is an absolute mess because we just keep building more and more stuff upon more and more stuff. And perhaps if we could just start again, we wouldn't be in the mess that we're in. But putting all that to one side, you know, I learned how to think algorithmically. And that was the crux of it. You know, I learned perseverance, resilience. Those were the key skills for me being successful. And it doesn't matter whether it's JavaScript or whether it's C++, you know, those things, they'll come and go. And it doesn't matter. I can't really hand on heart and, you know, say to a student, what I'm going to teach you now, you know, that'll be good for the next 50 years. Of course it wasn't. I mean, of course it won't be. I mean, we started this conversation with when I was learning programming, the internet didn't exist. Well, maybe the internet isn't going to exist in the future because it would have been superseded with something we can't even begin to imagine right now. So let's not teach the kids JavaScript. Let's teach the kids how to think algorithmically.
Yeah, I 100% agree with you on that. I feel like as long as you can learn something that you can create stuff with, sort of equally valuable, right? I mean, especially at that level. Do you think the one-to-one or laptops in all classes all the time is a good thing?
Yes and no. I think, oh God, there's a lot to unpack there. I think that the biggest problem that we've got is the digital divide with that at the moment. So if you're going to have one-to-one devices, then how are you going to make that happen? And it's not always, you know, as easy as it sounds. So you do have a real problem with the digital divide. If you can solve the digital divide and every student has a tablet device in the classroom, it can unleash that magic that we talked about earlier. However, you have to remember that students need to be educated to use the right things at the right times. And you know, here's another analogy for you. You wouldn't say to the students, there's a road over there. Your objective is to get from this side of the pavement to the other side of the pavement. Off you go. You don't, do you? You take them by the hand when they're very young and you say, right, let's look left, let's look right. Right, is it safe to go? Yes. Right, let's move forward together. Let's keep looking left and right. You know, that's how you teach the students to cross the road. Well, if you just give them a tablet and say, hey, we've got a magical new device for learning here. Here's a tablet, off you go. Then you've kind of committed the same offence as making them cross the road without any training. So it can be quite dangerous to do that in all sorts of different ways. But in essence, it's a good thing. I just think there are many dangers, and we've got to be careful of them. You know, that's still a very immature aspect of education at the moment. I'd like to think in the future, you know, we don't have any fear over a student having a pen and a piece of paper and a textbook. So why should we have any fear of them having a tablet? What's important is that we can enable every student to have that tablet, and that we can make sure that every student can be responsible with that tablet. And if we can do that, then we open the magic.
I see. And yeah, that's definitely something I've been thinking about more. I feel like a lot of these things on the surface sound, you know, fantastic, or, you know, almost, you know, like it'd be criminal not to give every student some kind of solid device, whether it's a tablet or a laptop. But when you unpack them, you know, unpack what it means to really roll that out at a school all of a sudden. I don't know, because I was part of kind of a one-to-one transition or rollout, and I thought there were definitely things that could have been done better, to say the least, with that. So,
yeah. Do you broadly think that if it could be well executed, it's a good idea, or do you just think that actually, no, that's not the future?
I definitely one-to-one for every kid. They should get like a MacBook Pro, or with beefy laptops that can do everything they want. Maybe dual boot like Ubuntu and Windows machines for everyone. But what I thought was what I thought was what was frustrating for me in the moment, and also looking back on it, was that there became this push to have the device all the time in every class. And I thought that was really probably counterproductive, because then I'm sitting in English class, and of course I'm coding in English class. And there is definitely plenty of stuff I missed in my education because of that.
Right, okay, yeah. The device is a tool. It's a tool in the toolbox, and I think teachers have to manage that tool like any other tool. I'm really fascinated by that subject. We could have a whole new podcast just on this, because I think it's interesting. A lot of teachers are quite fearful. If you take out the barriers of, I don't know how to use the devices, I don't know how to use the apps, I don't know how to teach that way, take all those barriers away for a minute. Not that they're not real, because they are, but let's just take them away. And what you get left with is, is this tablet a good idea or not? And is it, or am I just making this up? Is it not the same argument as a pen? And it's like, we could give you this pen. It's going to open the world to you, because now you can write and you can communicate ideas to other people, and you can do all these great things. And you can also graffiti the desks. And you can also snap the thing in half, and you can also poke someone in the eye with it. Now, because there are those three really bad things to do, does it mean we don't give them a pen? And I argue that, no, of course, that's silly. If you said to any teacher now, don't teach with pens, bad idea, they'd laugh at you. Well, I think the same will happen with tablet devices. People will laugh at us in 30 years' time, probably less time than that. They'll look back and they'll say, what do you mean some teachers didn't want the students to have a one-to-one device? That's nonsense. Yeah, that's what will happen.
Yeah, I think that's inevitable. But I just kind of feel like there's some, in the same way that there's magic to having it, there's also magic to not having it. You know what I mean?
Oh yeah, this comes back to it's a tool, and let's not become too dependent on it, because as I said earlier in our talk, just because I teach flipped classroom, does it mean that my lessons are formulaic and I always teach them using that structure? And my answer was clearly no, and that's the mistake that people make when they listen to me. They think, that's the way he teaches everything. No, of course I don't. And I think the same is true of this tablet. Use this device when it makes sense to use it. When you want to unleash the creativity and the independence in a student, then you might have a good opportunity to use it. Does it mean that you should put it away and you should get them running around and being active and talking to each other, face to face and doing other things? Yes, of course you should. It's about the right tools at the right time. And I think that's where people make mistakes. They just think that whether it's flipped classroom or whether it's, devices, in one-to-one devices, whatever it is, people always think that, now that's the thing we're doing. And it's like, all the things we were doing before now don't count. Of course they do. All you're doing is putting more tools in your toolbox, instead of using that screwdriver as a hammer, which you could do, which is not very effective, you put a hammer in your toolbox and use the hammer for hammering. And you know what? When it makes sense, put the screwdriver in front of the hammer, and you're going to get added value. So do all the things you did before, do the new things, and then crucially, with the screwdriver and the hammer, do the old things with the new things. And you're going to have such a good time in learning.
Yeah, 100% agree with you on that. I think this isn't just a problem like in education or CS, but but that element of nuance kind of exists everywhere, and frequently people, reasonably intelligent people, for whatever reason, don't spend enough time on it. So perhaps that's something to consider.
I don't think enough teachers question what they're doing. They were trained to teach in a particular way. They've got used to teaching in that way. It works, so they stop asking questions of themselves. And I would just encourage all teachers listening to just think, right, when you set them to do questions out of a textbook, pause, ask yourself, why am I asking them to do that? What's the reason? When I ask them to write a little essay, why am I asking them to write it? When I ask them to create an animation, why is the animation a good idea? And just question what you're doing and say, this is why I'm doing it. This is the outcome I'm looking for, and evaluate it. And if the outcome was what you were looking for, then fantastic. But don't then close your mind to that's the only way I'm ever going to do it, because there were probably many paths to success. You explored and found one of them. And if it's not successful, don't say that will never be successful. Evaluate why it wasn't successful. What were the reasons? Does it just need a little bit of tweaking? And then what you'll find is that suddenly it is very successful in ways that you didn't think it was going to be successful. So just take a step back, think, why am I doing what I'm doing? And that, I think, is the path to being a happier teacher. It feels more stressful when I talk about it like that, because it's like, oh no, I've got to suddenly evaluate everything I'm doing and change everything I'm doing. I can't cope with that. No, I'm not really saying that. I'm just saying, look at ways of making learning more enjoyable for you as a teacher, and so you can get greater outcomes. And if students get greater outcomes, it will be more enjoyable. Just by the very nature that they enjoy what they're doing.
Mm-hmm. Awesome. And I think that, just to kind of add one last thing here, I feel like that not necessarily consistent, but that sort of repeated feeling of achievement and success is really crucial from any learner perspective, even if I'm just going through a Elixir tutorial or something like that.
I agree.
That's really crucial.
Help learners be successful. Don't chastise them for being unsuccessful. That's part of the learning journey. Celebrate their success and enable them to be successful. And small steps will eventually take you a long way. Yeah.
Awesome. Perfect note to end on. Thank you so much, Dave. Any things you'd like to, any final words or things you'd like to plug in on our session?
Just thank you to anybody that's lasted listening to me waffle on for this length of time. If you know me, you know that I can't help myself. I have a real enthusiasm for teaching and teaching computer science, and hopefully that comes over, and that's sort of infectious. That's sort of what I want. But just thank you to the whole community, and thank you for making me keep asking the questions. Have I got everything right? Certainly not. Just keep trying.
Awesome. Thank you, Dave. With that, we'll end the live event. I look forward to more comments and questions afterwards as people find this on Facebook and YouTube. And hope this isn't our last time chatting, Dave. So with that, we'll pause the live stream. Thanks everyone for watching.
Absolute pleasure being here. Thank you for inviting me.
Thanks. Awesome. And that's it.